Hi everyone and welcome to this video. It's just going to be a really short one covering the topic of diatomic molecules. So there's sometimes a little bit of confusion when it comes to this part of the topic because there's kind of two parts of this little bit of knowledge that we need for chemistry. And sometimes what people do is they kind of merge the two together and think that they're just one thing. So we'll cover the two ideas together and just try to kind of make it clear that there's a difference between the term diatomic molecule and diatomic element. Okay, so we'll have a wee look at them as we go through. To start off with, just a really simple idea is to understand what the term diatomic means. So di in chemistry comes from the Greek prefix which means two. Atomic obviously is going to be referring to the word atom, and so a diatomic molecule is really simply any molecule that contains only two atoms joined together. So quite often the confusion comes not with the term diatomic, but actually with the difference between a diatomic molecule and a diatomic element. So first things first, a diatomic molecule can be any chemical that contains only two atoms in a molecule type structure. So a good example would be the gas carbon monoxide, which is a poisonous gas, and also hydrogen chloride, which is the gas that goes on to make hydrochloric acid. So carbon monoxide is CO, one carbon and one oxygen joined together. So one carbon and one oxygen make two atoms, and therefore that is diatomic. And the same would be true for hydrogen chloride, one H, one Cl, two atoms in total, HCl. I think the reason that the confusion comes in is that the vast majority of the questions that we deal with in chemistry regarding diatomic is going to be relating to the fact that there are 7 elements in the periodic table. Now remember, there's like 120 elements in the periodic table, and only 7 of them form these diatomic molecules. And because there's so few of them, we do expect you to learn them off by heart. So a lot of our focus then shifts to learning these 7, and people then start to mix up the idea of what diatomic molecule and diatomic element are, and the two kind of become one idea. So these 7 elements form diatomic molecules, okay? They form molecules containing 2 atoms. The difference here though is that both of the atoms that join together will be the same type. They'll have the same number of protons, the same atomic number. So the example that you can see on the screen here towards the bottom right is this idea that you're going to have 2 fluorines joined together by sharing this pair of electrons, forming a covalent bond, which is 2 fluorines joined together, or F2. And there are 7 elements that do that. So we've got the list on the left hand side here. We've got hydrogen and nitrogen, oxygen, fluorine, chlorine, bromine and iodine. Now we do expect you to learn these 7 elements off by heart, but we need to be very clear that they are not the only diatomic molecules that exist. They're just the only elements that exist purely as diatomic elements. Okay, so molecules which are diatomic where both of the atoms are the same. There's 7 examples, but there are lots and lots of compounds where you're going to have 2 different elements joined together to make a molecule. So hoping that we're clear on the difference between the term diatomic element and diatomic molecule, let's focus on the bit that I've already said we really need to focus on learning. We need to understand and learn the 7 diatomic elements off by heart, because there are a number of times where a question will involve the knowledge that you need to know that hydrogen, for example, doesn't exist on its own as a single atom, it exists as H2. So on the screen here, you can see our first example of a kind of method for memorizing the 7, which is the use of a mnemonic. Now there are lots and lots of these. If you have a look online, you can even make up your own. The idea being that you make up a phrase using the first letter of each element to make a memorable or funny phrase to help you to remember each one. So for hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine and bromine, we can take the first letters and we can change the words to have no fear of ice cold beer. It's something that's snappy, catchy and hopefully easy for you to remember in order to memorize these. Let's have a look at another example of how we could memorize the 7. So another way to remember the 7 diatomic elements, and I must admit the one that I prefer to use myself, is the idea that each of the 7 elements falls into the category of being a genuine Bulfinch element. Now, gen, ein, and Bulfinch are the 3 things that we can use to identify the 7 elements in the periodic table that are different from every other one. They form diatomic molecules. So the Bulfinch part, B-O-F-I-N-C-H, is the 7 elements as shown on the screen there: bromine, oxygen, and fluorine, iodine, nitrogen, chlorine, and hydrogen. The problem then becomes, if you remember Bulfinch or even Have No Fear of Ice Cold Beer, you end up with a problem where you have, for example, calcium or carbon, and you're then looking at those and thinking, well, they begin with C, are they maybe one of our diatomic elements? And because they're not, obviously chlorine is not the only element in the periodic table that begins with C, you still have to know which one it is. And in this case, it is chlorine. And that's where we bring in the word genuine. So to be a genuine Bulfinch element, you can see that the spelling I've got on the screen here is a little bit kind of exaggerated by the gen and the ein being capitalized. The reason for that is that every element in this list, these 7 elements here, are the only elements in the whole periodic table that either end with INE or end with GEN. So these become our genuine diatomic elements, our genuine Bulfinch elements. So I did say it would be a quick video. Here's a quick recap of what we need to know in terms of diatomic molecules. So the first thing is that a diatomic molecule is a molecule containing just 2 atoms. They don't have to be the same 2 atoms, they can be different. So for example, carbon monoxide is C and O, whereas fluorine is F and F. It's just the case that the 2 atoms are joined together, there's nothing else there, they are a diatomic molecule. For our periodic table, which contains, as we said before, around about 120 different elements, there are 7 that exist as diatomic molecules. These are our 7 diatomic elements, and we expect you to memorize the 7 and be able to write their formula. So for example, fluorine, which is F in the periodic table, becomes F2, and chlorine, which is Cl, becomes Cl2. Now, just to be clear, this is only when they're on their own. Fluorine will happily join up with a chlorine, for example, to form an FCl molecule. It doesn't mean that the 2 will always be present. It's just that these 7 elements will never be found on their own. Hydrogen and oxygen, really good examples that join together to make water, which is H2O. That doesn't mean that the 2 and the H is anything to do with the fact that it's diatomic. It's just that 2 hydrogens join together join with 1 oxygen to make a water molecule. It's really important that we're able to distinguish between something when it's an element, where it's not joined up with any other elements, and a compound, where it is joined up with other things. The term diatomic element for fluorine, chlorine, bromine, and iodine, for oxygen, nitrogen, and hydrogen, only applies when they're on their own. Okay, I hope you found this video useful. If you have any questions at all, obviously reach out and contact your chemistry teacher. We'd be more than happy to go over any points with you that you're still finding difficult. And hopefully you found it a useful process. Okay, have a great day.